Gustav Kirchhoff was a German physicist in the 1800s who applied his knowledge in the fields of spectral analysis as well as electrical circuits, hence the uncovering of his two laws of voltage and current. From these, equations regarding current and voltage were formulated, allowing calculations to be made. This further led to an easier understanding of Ohm's law and allowed James Maxwell to question his workings. The theory behind Kirchhoff's current law states that the current entering a junction or node will equal the current leaving that node, whether this be down one or more branches. Kirchhoff's current law upholds the conservation of charge, as there is no extra charge added or taken away from the system. It is easy to visualize Kirchhoff's current law by analyzing a river with a split. As you can see, the current entering at A will equal the current leaving at B and C. Hence, no extra current is added or taken away from this river system, further upholding the conservation laws. In example 1, we witness an array of currents entering and leaving a branch of wires. We know that the sum in the entire system should be equal to 0. When calculating I3, we can see that I1 and I2 will have an effect. Creating the equation and rearranging, we calculate that I3 equals 5 amps. Doing the same for I4, by creating the equation knowing that the sum will equal 0, we can rearrange the equation calculating that I4 equals 6 amps. We can then add all the now calculated values into the system and we see that it supports Kirchhoff's current law. In the second example, a simple circuit is set up with two resistors in parallel to a voltage source. Initially, we calculate that there is 24 volts across the resistors. Using Ohm's law, we then can calculate the currents I1 and I2. For the I1 calculation, we divide 24 volts by 8 ohms, leaving us with 3 amps. Similarly, with the I2, dividing 24 volts by 12 ohms gives 2 amps. Lastly, we can calculate I total by adding I1 and I2 to give 5 amps. To verify this, we can first calculate the total resistance, being the inverse of 1 over 8 plus 1 over 12, which equals 4.8, then dividing 24 volts by 4.8 to give 5 amps. Thank you for listening to my video.